morning, everybody. My name is Gaurav Chaudhary. I'm assistant professor in IT department at Ajay Kumar Garg Engineering College. The topic for today is KNN algorithm numerical under the subject of machine learning. So KNN here stands for K nearest neighbor. So before we proceed on to solving the K nearest neighbor algorithm numerical, we should know that what kind of machine learning problem is K nearest neighbor categorized into. So your K nearest neighbor is one of the most basic yet essential classification algorithms in machine learning. It belongs to the supervised learning domain and finds intense application in pattern recognition, data mining, and intrusion detection. So the thing is that it is a supervised learning problem. So why it is a supervised learning problem? Because one is trying to classify a point based on the known classification of other points. That is why it is a supervised learning problem. Now we will proceed on to solve our nearest neighbor clustering problem. So we are given 8 coordinates or 8 points in the Euclidean space, and we have to use the nearest neighbor clustering algorithm and Euclidean distance to cluster the examples from the given points. And we should here take some value of the threshold number, which is in this problem we are going to take it as 4. So here you have been given 8 points. So we have to cluster these 8 points into groups based on the K nearest neighbor algorithm. So what we will do is we will begin with the point A1 and we will assume that it is a cluster by itself. So your A1 point is a cluster by itself. The very first point you will just take it as a cluster by itself. You will make a cluster out of this very first point. So your first point A1 becomes a cluster K1 containing point A1. Now we have to see whether our next point, which is A2, 2, 5, whether this point belongs to this cluster K1 or whether it belongs to a new cluster K2. And how we will determine that? We will determine that by calculating the Euclidean distance between A1 and A2. So we are going to calculate the distance between Euclidean distance between A1 and A2. So the Euclidean distance denoted by D between A1 and A2 is, if we use the Euclidean equation, distance equation, this will be 2 minus 2 whole square plus 10 minus 5 whole square root. This comes out to be 0 square plus 5 square, which comes out to be square root of 25, and the final value comes out to be 5. Now the Euclidean distance between point A1 and A2 is 5. So we check this Euclidean distance against the threshold value, which is 4. If the Euclidean distance is greater than threshold, then your point under consideration, the coordinate under consideration, it will go into a new cluster. Had this distance come out to be, say, 3, which is less than 4, then your this A2 would have gone to the existing cluster K1. But because the Euclidean distance between A1 and A2 comes out to be 5, which is greater than the threshold value of 4, therefore this point A2 will go into a new cluster. So we will have to take a new cluster named K2, and that cluster will contain what point? That cluster will contain your point A2. So this is how it is determined whether A2 will go into the existing cluster K1 or it will go into a new cluster K2. So this is now what we have to do is we have to check for the next point. Now we have these 2 points are over. We have to check for the next point A3. So when we will check for the next point A3, we will calculate the Euclidean distance between A3 and A2 and the Euclidean distance between A3 and A1. So we will have to check the Euclidean distance of the next new point with respect to the existing clusters. With respect to the existing points and in the existing clusters. All the existing points in the existing clusters. So you will have to check the Euclidean distance of A3 with respect to A1 and with respect to A2. And whichever distance comes out to be closest, that distance you will have to check against the threshold value. If it is less than the threshold value, then it will go into that cluster containing the point which the new point is closest to, or if it is greater than threshold, then it will go into a new cluster. It will not go into any existing cluster. So now we calculate distance of A3 with respect to A1 and distance of A3 with respect to A2. We see that the distance of A3 with respect to A1, this will come out to be your 2 minus 8 whole square plus 10 minus 4 whole square. This comes out to be 36 plus 36 square root of, this comes out to be square root of 72. Whereas this value, this comes out to be 2 minus 8 whole square plus 5 minus 4 whole square. This is equal to 6 square plus 1 square. This is equal to under root of 37. So we find that your A3 point is closest to A2 as compared to point A1, because the distance between A3 and A1 is square root of 72, whereas the distance between A3 and A2 is square root of 37. So your A3 is closest to A2. Now this value, root 37, this value, because this is the closest distance, shortest distance, so we will have to check this value against the threshold value of 5, whether it is threshold value of 4, whether it is greater than 4 or it is less than 4. So this value is greater than 4. Root 37, it will be 6 point something approximate, and therefore that this value is greater than 4. So this implies that your A3 will also go into a new cluster. It will also go into a new cluster. So we'll have to form a new cluster K3, and this will go into a new cluster A3. A3 will go into this cluster. So this is till now, this is the cluster formation for our given points. Now when we go to the point 4, coordinate 4, which is 5, 8, then we will have to calculate the distance of dA4 with all the points present in all the clusters. That means we will have to calculate the distance of A4 with respect to A1, A4 with respect to A2, and A4 with respect to A3. So we will have to calculate all these Euclidean distances, and when we calculate all these Euclidean distances, so we will calculate all these Euclidean distances one by one. So A4 is 5, 8, and therefore with respect to A1, this is 5 minus 2 whole square plus 8 minus 10 whole square, square root, which is your 3 square plus minus 2 square, which is equal to 9 and 4, 30. Which is equal to square root of 13. Then we calculate the A4 distance between A4 and A2. So if we calculate distance between A4 and A2, this comes out to be your 5 minus 2 whole square plus 8 minus 5 whole square. So this comes out to be 3 square plus 3 square. So 9 plus 9 under root of 18. And the distance of point A4 with respect to A3 is 5 minus 8 whole square plus 8 minus 4 whole square. This comes out to be 3 square and 4 square. So 9 plus 16 under root of 25. So here we see that your point A4 is closest to A1. And so this point is selected because this is the closest point. And then we have to check for the against the threshold value. So root 13 is your root 13 is less than your threshold value 4. This will come out to be somewhere 3 point something. So this is your less than 4. So because the distance between A4 and A1 is less than 4, this means that the point A4 will go in the existing cluster K1 containing point A1. So this means that A1 will now contain A4 also. So this is your cluster configuration for the first 4 points. Now when we go to the point A5. So if we go to the point A5, we will see the distance of A5 with respect to A1, distance of A5 with respect to A2, distance of A5 with respect to A3, and distance of A5 with respect to A4. That means all the points which are there in the existing cluster. And when we calculate the Euclidean, these four Euclidean distances, we will find that your point A5 is closest to point A3. So your point, if you find all these Euclidean distances, you will find that this point A5, the distance between A5 and A3, this is the shortest distance of all the four distances. And this distance is 7 minus 8 whole square plus 5 minus 4 whole square, square it. This comes out to be 1 square plus 1 square, which comes out to be root 2. And this is less than the threshold value of 4. So this means A5 will go into the existing cluster containing point A3. Containing point A3. So A3 is contained in point A3. That means A5 will come here. So this is the cluster configuration for the first 5 points. Now we take up the next point, which is A6. And for A6, we will have to calculate the Euclidean distances with all the previous points which are there in the existing clusters. So all the points, the Euclidean distance of A6 with A1, with A2, with A3, with A4, and with A5. So you will be calculating D A6 with A1, D A6 with A2, D A6 with A3, D A6 with A4, D A6 with A5. So these 5 Euclidean distances will be calculating, and when we calculate these 5 Euclidean distance for the point A6, we will find that A6 is closest to point A3. So the distance between A6 and A3 is the shortest. And because the distance between A6 and the A3 is shortest, this is your cluster. A3 is a possible candidate for the new coordinate A6. So A3 is a possible candidate cluster for the new point A6. And whether this possible candidate cluster is going to be the cluster containing point A6, that will be determined by the threshold value. So we will check the Euclidean distance between A6 and A3, which is actually root 2. And this comes out to be less than 4. So that means the cluster containing A3 is going to contain the new point A6. So the cluster containing A3 is your K3. That means A6 will also be contained in this cluster. So we keep on proceeding like this, and we take up the next point A7, and for A7 what you're going to do is you're going to calculate the Euclidean distance of A7 with A1, Euclidean distance of A7 with A2, A7 with A3, A7 with A4, A7 with A5, and A7 with A6. So when we calculate all these Euclidean distance for the point A7, we will find that the distance between A7 and A2 is the shortest distance of among all the Euclidean distances, and the distance between A7 and A2 is 1 minus 2 whole square plus 2 minus 5 whole square, which comes out to 1 square plus 3 square. That comes out to be root 10, and your root 10 is less than 4. Because root 10 is less than 4, therefore A7 will go into the cluster which contains the point A2. So A2 is contained in cluster K2. That means now it will also contain the new point A7. So this is the cluster configuration so far for the first 7 points. Now moving on to the last point, A8. So for the last point 8, we will again calculate the Euclidean distance of point A8 with A1, A8 with A2, A8 with A3, A8 with A4, A8 with A5, A8 with A6, and A8 with A7. Now when we calculate all these Euclidean distance, we will find that your point A8 is closest to point A4. So the distance between point A8 and A4 is A8 is 4 minus 5 whole square plus 9 minus 8 whole square, which comes out to be 1 square plus 1 square, which comes out to be root 2, and this is less than threshold 4. That means your A8 will go into the existing cluster containing point A4, because the Euclidean distance between A8 and A4 is less than the threshold value of 4. So A8 will go into the cluster containing point A4. That means A8 will go into cluster K1. So thus this is our final cluster configuration, which is cluster K1 containing points A1, A4, A8, cluster K2 containing points A2, A7, cluster K3 containing points A3, A5, A6. And if we draw these clusters in the Euclidean space, this is how our clusters will look like. This is the final cluster configuration diagram. This is how the KNN algorithm is applied to the given set of points for a given threshold value. And this is our resultant clusters. This ends our topic of numerical on the K nearest neighbor algorithm. Thank you.